Good morning, everyone. Today I'm gonna do some presentation about comparison between gas metal arc welding (GMAW) and gas tungsten arc welding (GTAW). My name is Benny Bantanaklang from DKM 1A. Introduction to gas shielded arc welding processes. Gas metal arc welding that are known as GMAW, MIG welding. Gas metal arc welding are commonly known as MIG welding. It's a high productivity process where an electric arc is established between a continuously fed consumable wire electrode and the workpiece. As the wire melts, it becomes the filler material, eliminating the need for manual filler rod addition and allowing for a high deposition rate and fast travel speed. The entire process is shielded by a stream of gas, typically an argon and CO2 mixture, to protect the molten weld pool from atmospheric contamination, making it one of the most popular methods for industrial and manufacturing application. Gas tungsten arc welding, GTAW, and TAG welding are is an arc welding method renowned for producing the highest quality and most precise weld. In this process, the arc is maintained by non-consumable tungsten electrode, which generates intense and focused heat. Because the electrode does not melt, filler metal must be added sparingly by operator it required, giving the welder precise control over the weld pool. The weld area is protected exclusively by an inert shielding gas. Usually they use pure argon, which results in clean, spatter-free joints, making it the preferred choice for thin metal, exotic alloys, and applications where weld aesthetics are critical. First is method of welding and welding machine shielding gas and electrode used in both GMAW and GTAW. For the first method of welding, gas metal of welding GMAW is an arc is established between a continuously fed consumable wire electrode and the workpiece. The weld pool is protected by a continuously flowing shielding gas. Meanwhile, gas tungsten's arc welding (GTAW) is an arc is established between a non-consumable tungsten electrode and the workpiece. A spared filler metal is often added manually. The weld pool is protected by a continuously flowing shielding gas. And for the welding machine, gas metal arc welding GMAW requires a constant voltage CV as power source, a wire feeder mechanism, a torch with a conductive and a shielding gas supply system. Meanwhile, gas tungsten arc welding GTAW requires a constant current CC power source, a torch with a tungsten electrode, and a shielding gas supply system. It is often includes high frequency HF startingly flowing shielding gas. Meanwhile, for shielding gas metal arc welding GMAW typically use argon. Mostly they use this type of gas for aluminium and CO2 for steel, or a mixture like argon or CO2. The gas effects are stability and metal transfer. Meanwhile, gas tungsten's arc welding GTAW almost exclusively use pure argon or a helium or argon mixture. The inert gas protects the non-consumable tungsten electrode and weld pool from atmospheric contamination. For electrode, gas metal arc welding GMAW use a consumable wire. The filler metal fed from a spool must match the base metal composition. Meanwhile, gas tungsten arc welding GTAW is a non-consumable tungsten electrode. It can be pure tungsten or alloy with thorium or platinum to improve arc starting and current capacity. For tie current and polarity used in both Gmao and Jitao and the effect of polarity of the welding process, I'm gonna pass to the next person.
Good morning, everyone. My name is Hildebrand Mark, and I'm going to explain for the second one, the type of current and polarity used in both Jimao and Jitao, and the effect of polarity on the welding process. Type of current and polarity for gas metal arc welding is almost always use direct current electrode positive DCEP, also known as reverse polarity. This provides deeper penetration and higher material deposition rate because more heat is concentrated on the workpiece. DCEN, direct current electrode negative, is rarely used in GMAO because it causes the electrode wire to overheat and sputter. For gas tungsten arc welding (GTAW), direct current electrode negative DCEN straight polarity is used for welding ferrous metal, steel, stainless steel, etc. It concentrates 2 out of 3 of the heat on the workpiece, allowing the deeper penetration and minimizing heat on the tungsten. Alternating current AC is used for welding aluminum and magnesium. The switching polarity provides a cleaning action on the surface, breaking up the refractory oxide layer, which is essential for the metal. Next is effect of polarity. DCEP electrode positive. Deep penetration, concentrate heat on the base metal. Cleaning action for aluminum in AC welding. The positive half cycle help to sputter and remove surface oxides. DCN electrode negative. Shallow penetration, concentrate heat on the tungsten GTAW and or electrode GMAW. High deposition rate used in GTAW for a narrow deep well with minimal electrode erection. The third one is advantage and disadvantage comparison. GMAW advantage is high deposition rate, fastest, no slack to clean, unlike SMAW, continuous process, minimal starts and stops, easy to learn and automate. GMAW disadvantages, less portable due to shielding gas and wire feeder. Prone to porosity of shielding gas is lost. As example, wind. Thin material can be difficult to weld. GTAW advantages, highest quality weld, clean, precise. Excellent for thin metals, can weld almost all metal, including aluminum, titanium, no spatter. GTAW disadvantage, slowly welding, low depositing rate, operation skill require, and relatively expensive equipment.
So my name is Jekri Hesetua. Today I want to explain about common welding defect and prevention. Now is defect type porosity description. Gas bubble trap in the solidified weld metal. Second, prevention method. Ensure a clean base metal, no rust or grease. Check shielding, gas flow rate, use properly dried electrodes or filler wire. Now is undercut. A groove melt into the base metal adjacent to the weld toe, weakening the joint. Second, reduce welding current or speed, adjust torque angle, use proper weaving technique. Next is slag inclusion. Non-metallic solid material, flux residue trapped within the weld metal, mostly in small but possible if Gmao or Jitao uses flux core wire. Second is properly clean the joint and previously deposit weld pass. Ensure adequate paddle control. Next one is incomplete penetration. The well method does not fully fill the joint tightness. Then increase welding current, slow down travel speed, ensure proper joint preparation, wither groove angle. Now is crack, fracture of the well metal or base metal, crater crack, satellite crack. Second, proper preheating and post-well health treatment. Select the correct filler method. Ensure the joint design can handle residual stress. Selamat pagi, good morning, Techen How, and welcome to all of you guys who watching this video today. My name is Luis Fernandez, anak Kanang, and I'm going to tell you guys and present about distortion type and minimization technique. Okay. First, type of distortion. Transverse shrink, shortening across the width of the well. Longitudinal shrink, shortening along the length of the well. And then angular distortion, rotation that occurs when the center of the well is not aligned with the neutral axis of the path for the most common type. And then lastly, buckling or warping. It was large, wavy deformation often seen in thin plates. Okay, next slide. All right. Minimization technique. First, presetting or pre-bending. Placing the part in an opposite direction to the expected distortion so that the finish well corrects the shape. After that, clamping and fixturing. Using strong mechanical clamps or jigs to restrain the part during the welding. After that, tack welding. Applying small intermittent welds before the main welding to hold the parts rigidly in place. And then number four, intermittent welding. Using the non-continuous weld bit to reduce the amount of heat input. Before lastly, balance the welding backstep or skip welding. Welding in short segment or opposing direction to distribute heat evenly and counterbalance stresses. And lastly, minimum heat input. Using the lowest current and fastest travel speed possible while still achieving an quality weld. Alright, that's all from us. Yeah, bye bye. Thank you for watching and don't forget to like, subscribe and share.